Hi all, hope you enjoyed your break and welcome back to our second session of the day. For those who are just joining us, my name is Gordon McMillan. I am the chair of IGEM's Young Persons Network, and it is my great pleasure to welcome you to the 19th IGEM YPPC final. We had a great first session this morning where we heard from our first 5 finalists. We had Niamh and Sikander presenting on energy future projects, while Katie, Theo and Amy discussed innovative ways to improve operational efficiencies. We'll now be hearing from our next 5 finalists, ultimately crowning our 2020 YPPC champion. So to help the session run smoothly, can we ask you put your microphone on mute and your camera off. We will be recording this event and it will be available on IGEM TV. So moving on to the agenda, only one of our stellar contestants can be crowned the winner and take away a once-in-a-lifetime trip to the World Gas Conference 2022 in Korea. They'll also get their name engraved on the prestigious IGEM YPPC trophy. Our finalists each have 15 minutes to present their project and then 5 minutes to answer any questions from the judges. So if you do have any questions, please submit them via the chat facility where our finalists will have the opportunity to answer them from there. Our plan is to hear from our next 5 finalists, followed by one last break where the judges will get together and make their final decision. At about 1:45, we'll then all reconvene for our final session to crown our 2020 champion. So before we progress with this session, let's have a quick word with our judges. Our head of the judging panel, Duncan Wong, General Manager for Marketing and Sales with the Hong Kong and China Gas Company, and also our IGEM President, will be heading up the judging panel. Duncan, how have you found the event so far with the first session a couple of hours ago?
It's absolutely amazing. All the presentation are at very high quality. I'm amazed these young people. They are so talented, you know.
Superb, Duncan. Graham Cleaton as well joins us on our judging panel. Graham is Vice President for UK Operations for ULC Robotics. Being in the YPPC final panel is an annual highlight for Graham, and 4th time in a row. It's very different from previous sessions, Graham, but how does this compare to the last years and the years before when we were doing these events face to face?
Yeah, I must admit, Gordon, last year I thought would take some beating. I thought it was a super session last year, particularly quality of people and the way the overall ambience of the session. There's an obvious negative is down, you know, the fact that we can't interact with people. But I think so far that's been overcome by the fact that the technology and the way people have presented seems to have relaxed people nicely. And I think the quality of the presentations and the way they've come across is almost overcome the lack of interaction with people. So I'm really looking forward to the second session.
Superb, Graham. And the hosting skills as well would have helped with that.
That was the one negative, yes.
Jane Haswell finishes our trio of judges. Jane's a consultant with pipeline integrity engineers and highly respected in the gas industry. Jane was the deserved recipient of the Leadership Award in the 2019 Gas Awards. Jane, how have you found the event so far?
Thank you, Gordon. I would just like to confirm agreement with the comments that Duncan and Graham have made. The quality is absolutely excellent and I've learned a great deal. It's an excellent event. Okay,
thank you, Jane. So that's our judges. Now we'll move on to our finalists, and it's a pleasure to introduce you our first finalist of session 2, Stuart Sherlock, Innovation Project Manager from SGN, and our Scottish section winner. Stuart's going to talk about trenchless technology. So over to you, Stuart.
Thanks, Gordon. Let me just share my screen for you. So easy to see, Gordon? Yep.
Yep, loud and clear.
Cool, perfect. So hi everyone, thanks for giving me this great opportunity today to present on my project on the foam annular sealant through keyhole, which is now completed and has since seen the implementation of a product called BurstPack with the project partners Steve Vick International, which is now rolled out across the utility industry. To give a quick introduction, my background is in mechanical engineering and I gained chartership with IGEM last year. I work within the innovation team at SGN, and my role involves managing a number of innovation projects that aim to improve our operational activities. I also sit on the IGEM Scottish Committee Group, and I am also the Scottish Chair for the Pipeline Industry Guild Young Persons Group called the Professional Development Network. And my plan today is to go over some of the points listed here and to give a background on the project, the current processes, what was involved within the project, such as the development and trials, and what my involvement was. So SGN carry out a number of operational activities, including the replacement of old metallic gas mains, repair and maintenance of our pipelines, and also emergency work. And these images here on the slide are just some of the examples of the work carried out, where during these activities, SGN has an obligation to minimise the disruption to customers. And along with this obligation, SGN have targets to carry out replacement of 1,000 kilometres of metallic mains and 20,000 connections each year. And what this emphasises really is the large workload that we are required to carry out and the potential disruption that it can have. And the project that I was responsible for aims to reduce this obligation and workload by making our operations more efficient, helping to minimise this disruption to customers. In some areas that this can be achieved is by utilising smaller excavations, working efficiently to reduce the time spent on site, and which ultimately helps to reduce our carbon footprint and emissions. And really the overarching goal here on the right is focusing on our customers while carrying out our key operations. So SGN are working on ways to reduce this disruption through innovative techniques and projects that allow for more efficient ways of working during activities such as your service connections, your mains replacement, and any repairs. In projects like iCore, they aim to improve these efficiencies and safety on site by operating in a smaller excavation, such as the circular keyhole shown here on the right image. And the project also utilises long-handled toolings for doing operations such as your service connections, which removes the operative from the excavation. Other projects such as the robotic roadwork excavation system also aims to reduce the site footprint by automating certain operational activities by utilising a robot. And both projects, these examples aim to maintain safety and efficiency while carrying out our operations. So I've included some images here on this slide just to show the traditional site conditions and what our projects are looking to reduce. And the images here highlight the complexity and the size of traditional excavations, where there can be multiple services that you need to take into consideration, as shown on the left, and also the large equipment and road barriers shown on the right. The conventional square-shaped excavation shown in the middle can often fail as a result of traffic impacting on the corners, which effectively hold a high stress zone. And these can crack and create potholes, which I'm sure everybody has experienced at some point. And this is not an issue seen just within SGN, but something experienced with all the gas, electricity, and other utility companies. So looking at these innovation projects and techniques, they all aim to make our operations smarter and efficient by using technologies such as your long-handled tooling and utilising keyhole coring, creating a smaller and stronger excavation. And one thing that clearly points out is by having no corners with these circular cutouts reduces the stress zones and likelihood of the surface excavation failing. And you can also see in the top right image that the reinstated core excavation is back to its original state. To give a visual appreciation of the benefits that these innovation techniques can have, these images were taken from another robotics project, and they highlight that by using innovation and different techniques can help improve efficiencies to create a reduction in site footprint and traffic management. And in order to increase these efficiencies and reduce the site impact, the burst pack product is used during your main replacement activities when carrying out service connections to reduce the time spent on site and the size of excavation. So just to give a quick overview of the service connection operations, the current metallic infrastructure within the utility industries is aging and requires to be replaced with plastic or polyethylene pipes or PE pipes, meaning new service connections to each property needs to be made. And the first step for the service connection involves inserting your PE pipe through the live or dead metallic main, resulting in a gap or annular space being created between the differences in pipe diameters. And then the metallic main is opened, exposing the PE pipe for your service connections. And once it's been connected and before the reinstatement can be made, the annular space must be closed. And this is to prevent issues such as your soil backfilling into the annular space, which can cause the surface to slump over time, again, leading to potholes and further disruption to customers. But it's also required from a safety point of view to prevent gas leaks from travelling along this annular space. So the current process of sealing the annular space, typically using a foam mixture, involves preparation, mixing and then applying, whereas it is an expensive and overcomplicated process. And the example here shows a typical method of mixing the foam chemicals and pouring it into the annular space. And as you can see, there's a high risk of spills and it's quite hazardous to the operative, especially when working in confined space with other utilities, as previously shown in the other slides. And for the service connections, there is a requirement to fill both sides of the broken main, as shown in the bottom picture here. And just to summarise this current technique, it can be dangerous, takes time to prepare and also apply, and can be expensive when you consider the thousands of new connections required. So by identifying these issues with the current method, I was able to set a project problem statement here and agreeing to develop a new, safer, reduced cost and simpler method of closing the annular space. A list of project requirements were also made with input from the operations team, such as being user-friendly, safe to handle, and at a suitable cost. So at the start of the project, I attended the site with the field operatives to gain an understanding of the operations and the problems faced, as well as getting their input into the project. I then gained an understanding of the required policies, such as SGN's main service lane procedures, and also industry standards such as your gas industry standards GIS LC 14, which is a specification for annular gap sealants. So by doing this, I was able to develop a product that met both current processes and standards. And then by taking all this information, I developed a new product called Burst Pack, which consists of a two-part sachet design, pre-measured depending on the size of annular space that needs to be filled. And this is shown in the right image, consisting of the foam chemicals with the specially designed release points. And we focus these designs to be used on tier 1, 4, 6 and 8 inch pipelines. The user follows the same steps as before for preparing and mixing before applying by hand or long handled tooling in or outside the excavation. So the now mixed sachet would go through its chemical expansion, where it would burst out the leading release points, successfully filling the annular space, as you can see from the bottom right picture. So comparing this to the existing method is a more user-friendly design, making it safer to handle. It can be applied from outside the excavation, again, making it safer by removing the operative from the excavation. And it can be applied in a reduced time, with the whole operation taking just a few minutes compared to around 20 to 30 minutes with other methods. And again, both sides of the metallic main must be applied per excavation, so you're looking at up to about an hour saving. As mentioned earlier in the project, the project was in partnership with Steve Vick International, who are the experts in this foam technology and helped design and develop the product. The project lasted 12 months and was funded through Ofgem's Network Innovation Allowance funding incentive, and I'll go over this a little bit more detail towards the end of the presentation. But the project followed the Technology Readiness Level, or TRL, scaling shown here, where earlier TRL levels of research was carried out by the project partner before we started. So we started the project at TRL of 4 and ended on 9, with focus on technology development, demonstration, and then testing and implementation, all shown by the images here on the slide. So the first stage under TRL 4, technology development, involved gaining an appreciation of the task in hand and carrying out some initial tests. A few modifications were then made to find the best burst pack design that successfully met the project requirements and the problem statement outlined earlier. Under TRL 6 demonstrations, we took the prototypes out to site to get input from the operations team, and this was for both by hand and by long-handled tooling demonstration, where I created the appropriate documentation, such as your SEN testing and risk assessments documentation for using prototypes on site. After gaining feedback from the operatives, the final phase, TRL 9, involved testing of the burst pack on live operations under SEN policy documents, including the G23 document listed here, and also recording the output. And overall, the testing was all a success, with all annular spaces being sealed, as shown on the results section on the right. And the final section to this phase involved implementation, where the burst pack has now been rolled out to the wider industry by the project partners at STVIC International. So feedback in general was very positive from the operatives, but they could clearly see that how this addressed the problem of conventional methods, and were actually very enthusiastic about using it and getting their hands on it, because they found it was really easy to use. And just to summarise again with this slide taken from earlier on, the project achieved the project problem statement outlined at the start, as well as the project requirements listed here, by creating a more efficient and safer system. So just reflecting back on the projects and the skills and roles that I had to take on, and also the ones that I developed, it gave me really a greater appreciation of the operation activities, in particular areas such as safety. I was also able to demonstrate project management skills, from just doing your admin tasks to qualifying procedures and policies, as well as evidencing the benefits and outcomes. I developed my communication skills by interacting with other disciplines internally and at STVIC Internationals, and also leadership skills from steering the project and managing teams during the design and testing stage. And just the last few sort of slides here, really if anybody wants to know more about the project, as mentioned earlier on one of the previous slides, it was funded through Ofgem's Network Innovation Allowance, which has its own governance criteria to follow, and this includes reporting on the project progress, which can be found within the Energy Network Association website under the Smarter Networks portal link shown here. And then project information can also be found on SEN's Innovation Annual Report, both on the SEN's website and the portal link here. And these reports we do every year, they have snapshots of our projects, and as you can see from the screenshot on the right, this project is included alongside the ICOR project mentioned earlier under the mains replacement themed projects. So that's all from me. Thank you very much for listening, and I'll pass you back to Gordon.
Superb, Stuart. Brilliant presentation, and a great example of the innovation process for managing to overcome the different TRL levels. Okay, so we'll come to Duncan for our first question. Over to you, Duncan.
Stuart, it's an excellent presentation, and the materials are very good. I just want to know, have you done any calculations on the quantifiable benefits changing from this method compared to the previous one?
Yeah, sure. So with all of our projects, there always has to be some investment, or effectively you have to demonstrate the benefit before really doing any projects, and that is one of the purposes for doing innovation, is to try to improve or to demonstrate before you start the project of what the benefits are. So we did do some calculations, some cost benefit analysis, to sort of understand what the financial gains were, but then during the sort of lower sort of TRL 4, maybe TRL 6, from the demonstration we could actually get our hands on in a real live site basis almost, to see how long is this really going to do as in a real life environment. So we could take that timing, for example, and then we could compare it to the previous methods, which we've obviously been doing for quite a few years. So we could compare side by side what the time savings were from the development stages.
Yeah, thank you. I think one more thing is about, I saw one of your slides you mentioned about the traffic interruption. It will be a smaller sort of a working space. So I think it will also help the city congestion as well. Thank you.
Thanks.
Brilliant. We'll have a question now from Graham.
Stuart, very polished, thank you. And a great subject matter, as you know, close to my heart. I just want to build on Duncan's question really around what commercial analysis have you done around this, of the benefits, and then to build up on that, about your view on how it gets shared outside of the bigger arena of the networks outside of SGN. Any thoughts around that, Stuart?
Yeah, of course. So your first point, obviously the project was with Steve Fick International, so they are effectively one of the leaders on this foam technology and have a good connections with all the utility companies. So really, it was between us, SGN, and Steve Fick to sort of get the word out to talk about the project. But part of the Ofgem funding incentive is that we share the learning with all the other networks, and not just the networks. It's available for other utilities. So under the Smarter Networks portal, link the second last slide, for example, we do upload our projects onto this portal. All the information's there. It's got sort of like a project introductions. It's got closure reports. It's got all the benefits and evaluations that we've done throughout. So the learning is there. It does get shared through other committee groups that we have. So we've got groups that we speak to the other gas networks, and we share the learning through areas like that as well.
Thank you, Stuart.
Thanks.
Great stuff, Graham. And we'll have a last question from Jane.
Thank you very much. Stuart, that was a very good presentation. Thank you. Dealing with a difficult area of work, so anything that makes it easier for the operatives is excellent. Can you explain, in terms of doing the trials and the developing the product, did you come across any things that could go wrong?
Yeah, so it's something we do with a lot of our innovation projects, is take the lessons learned from just managing the project, for example. So we found that by having early engagement with the operatives, got them on board quite early. So we sort of addressed any problems that we could face. And I guess this was really from having clear communications and almost creating like a working group that you could communicate with the operatives, and the operatives on the field, and obviously the managers in terms of getting the correct site. So we did have a couple of issues of just trying to find the correct locations. So as I said, it was for tier 1 and different sizes within that one, within that range. And it was all about really having planned work that we could go out and trial. So we did have a few issues with just getting locations, but we overcame them just by communicating really clearly, really.
Okay, that's excellent. Thanks, Stuart.
Thank you.
Great stuff, Stuart. So that concludes your presentation. Well done for a great project and a great style of presentation. So well done, Stuart. You can relax. We'll now move on to our second session presentation in this session. We're going to hear now from Rebecca Senior, who's an engineer at Rosen. Rebecca won our North East and Yorkshire section heat, and she's going to talk about satellite imagery, using satellite imagery to detect flooding. So over to you, Rebecca.
Hi, thank you. Is it possible just to request control there of the presentation, please?
Sure.
You need to request it, and then I will.
It's just saying it's disabled by the sharers administrator at the moment.
Okay, do you want to try again quickly?
Yeah, that's still coming up.
It shouldn't be. Okay. That's not. If you don't have a copy, I'll just control it, and you just tell me when to move on.
Okay, great. That works. Thank you very much. So good morning, everyone. I'm Rebecca Senior. I'm an engineer at Rosen. I've been a graduate for just over 2 years now. Today, I'll be presenting a project that I've recently worked on, which is how synthetic aperture radar SAR imagery can be used to detect flooding. Next slide, please. Sorry, is Simon? Is that are you controlling it? Sorry.
It's moved on at my end.
Oh, it's frozen still on mine. Still the initial slide for me. I can come back to you with sharing the presentation if you give me time to set that up.
Yeah, no problem, Rebecca. We'll give you, we'll move on to the next presentation and give you a bit of time to set up.
Great, thank you.
Okay, no problem. Okay, so we'll speak to Rebecca after David's presentation. David, are you okay to continue?
I'm having the same issues as Rebecca here, so I'm just setting up my presentation as well.
Okay, no problem. Crystal, are you able to continue? No. Crystal, can you hear me? We'll cut this out in the final edit.
Move on to Ben.
Okay, so Crystal's not there as well. Ben, I see you're there. Are you in a position to step in?
I can, yeah. Give me 2 seconds, and I'll just share my presentation, guys. No problems.
No problem. What we'll do, we'll sort out the issue with Rebecca, and then just continue the schedule from Rebecca, David, and then Crystal. But Ben, thanks for filling in. Take your time to get settled.
No worries.
Okay, so we had, sorry for the technical glitch there. So from our Scottish section, Stuart Sherlock, we're now going to go south of England to our London, Southern and Eastern section winner. Ben Croxford is a senior business partner for SGN and works in the SHE development team. Ben's going to talk to us about driving transformational change in the gas industry. So over to you, Ben.
No problem at all. Gordon, can you see my screen before I begin?
Yep, it's looking brilliant.
Brilliant. Well, thank you very much for taking this time this morning to listen to my presentation. But before I begin, I've got some questions I want you to think about. Does your business, does your department, do you need to improve productivity? Do you need to be more efficient? Would you like to see a reduction in your fines and increase in your customer scores? The answer is probably yes. And you probably heard about digital transformation and how it's revolutionised the industry. Well, my name's Ben Croxford. I've been with SGN 12.5 years and started off my life as an apprentice in the South London depot. I progressed as an engineer and into life as a team manager. I then developed my career into the health and safety team and into my previous role as senior business partner, leading on organisational culture strategy, health and wellbeing strategy for SGN, and all of the safety related projects. And today, I'm going to take you through on how I'm leading digital transformation in SGN, where the journey began and where we are today. So sit back, relax, and buckle up for a journey. So we all know SGN and utilities worldwide are under pressure. Our regulators are demanding more efficiency for less. Our customers' expectations are increasing exponentially. They're demanding a greater reliable service with greater transparency. Now, to keep pace with this change, we've got to think differently, work differently, and collaborate more. And leveraging digital technologies are pivotal in the success of keeping pace with this change. So it's clear we needed to adapt at SGN, but how do we do it? Where do we start? How do we implement something of this scale? We simply didn't want to follow industry in this emerging digital race. We wanted to lead the way. But to do that, we needed expertise in this field, combining our gas industry experts with digital experts. And that's why we decided to team up with Boston Consultancy Group, Digital Ventures, in an exploration journey. And that's where I've come in. I was hand chosen by the exec due to my past successes and my past projects, and because of my operational and safety experience. I was chosen to lead the SGN embedded team to work hand in hand with BCGs, adopting their lean and agile working practices and their ethnographic research and strategic design. Now, being an engineer manager myself, one of my core imperatives was to make sure that us as a project team immersed ourselves into the day-to-day lives of our frontline workforce, not just senior managers, but focusing purely on the team managers and the team leaders that are the frontline workforce. The reason we do this is, from my experiences, both of those roles, is that IT projects and solutions often have the greatest intentions, but they're often seen as being done to the employees and not had a hand in the collaboration journey that led to the implementation of that product. So I wanted to change that. And what we did is we focused on where the biggest challenges were for not just our team managers, but also our engineers.
Thank you.
So to do that,
Dad's going to come up.
The biggest challenges that we faced from our team leaders' perspectives were that they were often filling in paperwork from memory. Things like risk assessments were seen as tick box exercises, which concerned me. And WhatsApp was being used as a workaround to communicate better and communicate and collaborate in a more streamlined fashion. And it's a behaviour that we lent into, which I'll describe a little bit later. And from managers' perspectives, and obviously I can relate, is that they wanted to be everywhere at once, but simply couldn't. All that information is tracked on paper that the team leaders fill in. And that lack of visibility on jobs made inefficiencies all over the place. Having to make phone calls and visit sites to get updates on jobs was just not what they needed. So we went and collaborated on solving those problems. And we had 36 weeks to do it. So we worked side by side, the teams, on a daily, weekly basis, testing ideas with them, building solutions, getting their feedback, informing the product. They were extended project members of the team. Every decision that was made with their input, not senior managers, but them and their managers. But not only was I leading on the collaboration journey, I was leading on interviews with utilities worldwide to see if the problem spaces were similar with SGN. And the reason that was important was we wanted to solve a problem for utilities worldwide, not just SGN. So I was fortunate enough to lead, because of my experience, on interviews with CEOs, with utilities from Chile, Italy, all the way down to frontline supervisors to understand their problem space. So that informed our product build. The surveys and the interviews also fed into how we developed the business case, which I'll touch on a little bit later. But some of the insights this close collaboration gave us for the product build was that we found out things like 10% of our workforce are colourblind. And some of the project team that we were working with actually were colourblind, which informed how the products looked and how the application colours were used to make it easier for them to use on a daily basis. So what did we build? Well, we built Field. Field is a digital application that transforms the day-to-day lives of both field engineers and managers. It allows team leaders to capture data effortlessly, giving their managers real-time visibility of site activities and giving actionable insights to that job. Rather than digitising a process, it's transformed it. We haven't just simply digitised the risk assessment, we transformed the risk assessment into being the initiating factor to a job that gives so many insights to a manager's day, but also giving support to the team. We're using the latest technology like voice recognition systems and a machine learning algorithm that allows us to learn and predict when certain things are going to happen and informs us on similar behaviour, which I'd love to answer some more questions on later. But what Field really does is it allows our managers to make data-driven decisions in real time to act on things before things go wrong or before an accident occurs. I'll give you a bit of an insight into how we built it. So we lent into that behaviour called WhatsApp, and we started risk assessment. And because I was, I'm not having, from a safety professional, I'm not having risk assessment being seen as a tick box exercise. So I asked the team to stop doing the paperwork and gave them a phone and said, go on WhatsApp and video your risk assessment. And it was a bit of a shock for the team, as you can imagine. But what that allowed me to do was understand how they would articulate a risk assessment. I would then sit, look at the video, type in the hazards and controls, send it back to them to ask them if I captured their risks and hazards appropriately. And that was the basis of our application. So that is an example of a lean test that we did from the 4 team leaders that I chose and the team manager to work on that experiment. That then allowed us to understand what insights this gives the team manager, what insights this gives us as a safety team, as a policy team. So not only can we understand the policy gaps, but also where we need some training, the change management strategy, and support for the teams to make better quality videos. So where did I lead? I'll talk about COVID in a moment, but stakeholders was where I had the fun and what I want to call out today. I had the opportunity to present the case to our shareholders, which is like going into the dragon's den, to be honest, which is a rare occurrence. You know, some of our exec don't even get to go and present there. And I was asked to present the case of why they should invest in the product that we was building and the benefits that it would give. So I could voice the concerns of the workforce and the challenges they faced, but I could also speak from experience. And I could articulate that in such a way that spoke to that seniority of how the business would benefit from this application. And it was a great defining moment and gave me a great confidence boost for the rest of the project that I had to present them to again thereafter. But I was going there for, the vision I had fulfilled, but also the impact it'd have to my colleagues on the front line. The other set of stakeholders I want to mention that some of you in the audience would know all too well is the HSE. Because we was encroaching on something as fundamental as risk assessment, I wanted to make sure they were brought along for the journey. So I spoke to my local inspector to say, look, I want to present you what we're working on. And he asked me to present to his executive team at the HSE and the principal inspector, because they themselves were setting their own strategy out about how they were going to keep pace with emerging technologies from a regulation perspective. And for those of you that know the HSE, they're not going to ever say that you're 100% right or you're doing things perfectly, but they will definitely say things if you're off piece, which I'm glad to say they weren't. They were delighted with the way in which we were working, and they're very interested in some of the analysis that I made about the risk perception of our workforce not being as high as we'd like it due to the fact that paperwork had been seen as a tick box exercise, and some of the behavioural insights that this was giving us from a proactive perspective now that we had real site visibility, which is a massive success and a breath of fresh air and a sigh of relief for our stakeholders at the exec, because that could have been a make or break for the project. So my personal insights and lessons learned. I was fortunate enough to have a leadership team that was brave and believed in us, believed in me to lead the SGN team, but to also try something new. And without their buy-in, this wouldn't have been successful. Stay true to the problem. The 6 challenges I spoke about earlier, we'd never pivoted away from them. Not one feature, not one application got built, or one part of the field got built without the team leader benefiting from it, the team manager, and SGN wider. So we stayed true to the problem we were solving. So the benefits. Remember, I built something not just for SGN, but with utilities worldwide in mind. And these are some of the benefits you'll see, and some of the benefits we've seen at SGN. That increase that increase in visibility and transparency and what it leads to. Increasing our safety performance and risk perception, increasing our spans of control and productivity of the job has been immense, and it's got wider scope for benefits outside of SGN. It wouldn't be right without me talking in the current climate about how COVID affected the project. And to be honest, it was my defining moment. It was 3 days before we was presenting to the exec on our implementation strategy, the traditional method of face-to-face training, booking hotel rooms, and the COVID struck. Project was put on hold. Operations and the executive team had to focus on how they were going to combat the COVID curveball. And to be honest, I was gutted. And before this project, I honestly would have sat back and accepted being put on hold till April 2021. But I couldn't do it. I had such a strong vision for how not only this could be the catalyst for change within SGN, but it'd be fundamental in how we would respond to COVID, because it was built for remote working, remote support, and everything that COVID threw at us. So I was brave. I put a proposal together to a couple of members of the project team that helped me put the content together over the bank holiday weekend to present to the exec to say, these are the risks, this is the opportunity, let's be brave and let's make this successful. And not only did I get approval and they bought into what I believed in, but we made it a success by rolling out remotely to 850 users at SGN for the first time only, with no face-to-face training. And the way we did that, an example is that we took the same approach to how we built field, I chose 4 team leaders, I chose a manager, we tested the content I put together, we tweaked it, we reviewed it, we scaled it, improved it, and ultimately it led to success and has now been the framework for how we do training at SGN. What did I deliver? Absolutely leading the way in digital transformation. Built benefits wider than just SGN. We overcame those challenges from the workforce and the team manager's perspective. I overcame multiple challenges. COVID-19, change management, self-belief that I had in myself. We implemented it, and not only that, we've built a company out of it that's launching to other utilities around the world. And it's allowed us to commence on this cycle of continual improvement. So I started off my presentation with what does it take to drive digital transformation and talk about all those benefits. It takes collaboration, it takes working differently and certainly thinking differently. I just want to leave you with what I've written in my paper about what I believe is the critical factor to digital transformation. And it's easy. It's your greatest asset, which is your people. And our leadership team absolutely believed in our people by believing in me and me believing in our workforce. And know if you can get the buy-in, if you can get the vision and the desire to change with the right tool to enable it, your workforce will transform your business and lead to all of those beneficial gains. Field has been built by the workforce for the workforce. And I just want to say thank you very much for your time. Happy to answer any questions. And this is what our workforce had to say during the build of Field, which is some of my proudest comments that I anchor to. So thank you very much for your time. Appreciate it.
Excellent presentation there, Ben. Excellent to see sort of a partner that's not traditionally used or known in the gas industry and bringing them into creating a really good beneficial product there. We'll come to a couple of the judges now, Ben, to ask you some questions. So first we'll come to Jane. Do you have a question for Ben?
Thank you. Yes. Yeah, Ben, that was excellent. The Field is obviously a really major development. You mentioned earlier in your presentation about the use of the machine learning algorithm.
Yes.
Can you just give a little more information about what came out of that, what it gave you?
Yeah, absolutely. So the way the machine learning algorithm works is that every team leader that does their risk assessment identifies hazards and controls. And what the machine learning algorithm does, it takes those hazards and controls, type of job that they're on, and the location, and all of the other team leaders that then do their risk assessment. The machine learning algorithm prompts the user to think about those other hazards controls that have been picked up on other similar job types by their colleagues. So what you have, in fact, is another support mechanism to make sure that the risk assessment is suitable and sufficient, because you've got different experience levels of risk perception and experience levels within your teams in the operational remit. So the machine learning algorithm learns off of people and then teaches the other members of the workforce by prompting them on similar jobs.
Excellent. That was great. Thank you, Ben.
No problem.
Superb. We'll come over to Graham now.
Super presentation, Ben, and a great subject. Ben, I want to move forward, if you don't mind, and hear from you about, your experiences that and the attributes that you've picked up in this process. How do you feel they're going to help you in moving forward, and which ones particularly?
I'll take one that's true from the heart, Graham, for me. And I've left school at 16 as an apprentice, and I've worked my way, through the ranks at SGN with passion and energy. I always had this misconception that I needed education, and I haven't got a degree or anything like that. And when I was fortunate enough to work with BCG and the project team, there was people there that would have Harvard education and working with highly intellectual individuals. And there was always a bit of self-doubt within me that I couldn't progress my career because of that educational gap. And this project has helped me prove that wrong. Not only does it not put me at a disadvantage, I'd say it puts me at an advantage, because I was able to get credibility and buy-in from the workforce. That same credibility allowed the exec and our shareholders to listen to what I had to say, and it led me to be confident enough to put a proposal together to make sure the field was used in the COVID response, and ultimately led to the catalyst of change at SGN. So I hope that answers your question, but for me, that's one of the biggest lessons I've learned, which is to be, stay true to your roots, and use that as prompting your self-belief.
Perfect. Thank you, sir.
Great message, Ben. And lastly, we'll come over to Duncan for our final question.
Thank you, Gordon. Ben, very powerful presentation. Very good. Picking up on your mottos of think differently, work differently, and collaborate more, how do you instill these ideas into your action to communicate with your staff or with the team?
Absolutely. So in terms of thinking differently, so from the very get-go, we thought differently by going on a collaboration journey. I think Gordon mentioned at the start, BCG are new partners and field are new partners for us to work with. We knew to adapt to change, we needed to change the way we've worked. So we started to use those agile and lean methodologies that we've now brought back to us at SGN. Work differently. I mentioned the change management framework and the face-to-face training. That's now no more SGN, and we're going to complete remote rollout of training based on this new ways of working. And the reason, Duncan, that's been successful ultimately is through collaboration, because without it was quite simple when you break it down. All of the ideas on how to make this successful come from the engineers, and they come from the managers, because they're the people that are going to be using it, and they're the people you're going to be training. So we had an idea, we tested it with a small group of people, we learned what we needed to learn, we adapted, we reviewed, and then scaled up our approach. So we then went from, say, 1 manager and 4 teams to 2 managers and 8 teams. Learn a bit more, reviewed, adapted, and improved. So that's how we tackled thinking differently and collaborating differently.
Thank you, Ben. You answered all my questions. Thank you.
Okay, congratulations, Ben. That was brilliant. Superb presentation and well done. So we'll move on now to our third session, our third finalist within this session, continue the digitisation sort of theme. We're going to hear from Rebecca Senior, engineer at Rosen. Rebecca won the North East and Yorkshire section heat, and she's going to talk about using SAR imagery to detect flooding. So hopefully this will go okay, Rebecca, with the technology. So it's over to you. Slides are looking good. Just need to unmute yourself, Rebecca.
Hi everyone, hopefully this will go a bit smoother this time. Can everyone see the slides?
Yep, looking good.
Okay, great, thank you. Good morning everyone, I'm Rebecca Senior. I'm an engineer at Rosen and I've been a graduate for just over 2 years now. Today I'll be presenting a project that I've recently worked on, and this is how synthetic aperture radar, SAR imagery, can be used to detect flooding. So just to introduce the problem that the client had, they noticed an increase in flooding on their 900-kilometre line, and this was due to the spring thaw and snow melt in Kazakhstan. The flooding may be linked with climate change or more localised cyclic changes. This increase then raised concern over the condition of the pipeline and the associated infrastructure's ability to resist the impacts of flooding. Flood defence mechanisms had been used, but with very little success. The objective of this project was to employ a method that could be used to detect, define and quantify seasonal flooding and establish any trends in the magnitude of flooding events. This would then ultimately assist with the planning of locations and scheduling of protection methods. And the method in which the objective was satisfied was to use SAR imagery, as the title of this presentation states, and I'll go into a little bit more detail later on about SAR, but this is a radio wave technique used to measure the backscatter and reflectivity of objects on the ground. So why is flooding a problem? Well, flooding can threaten the integrity of a pipeline and any associated infrastructure. I've listed a few hazards here, such as scour, erosion, and encroachment on the pipeline. And these are just a few of the ways in which the pipeline can be affected. And as we can see in the aerial imagery to the right of the screen here, this shows the damage to a bridge and right-of-way access road. This pipeline actually runs parallel to this road and is situated just north of it. So any damage that has happened to the road by flooding, that water has already crossed the pipeline. So flooding can result in exposure of a pipeline due to scour, and this can potentially cause adverse loading on the pipeline. Hydrodynamic loading on the pipeline from the river current can cause the pipe to displace laterally, as you can see in the image below on the slide. A more serious loading threat occurs due to vortex-induced vibration, and failure can develop rapidly due to fatigue. These loads depend on the length of the exposed span, the river current velocity, as well as the pipeline mass and soil properties at the shoulders of the span. The pipeline can be temporarily or permanently exposed during a flood event, and this is shown in the image on the right slide. Temporary exposure is not uncommon at river crossings. This is because a scour hole develops as the channel flow velocity increases during the flood development. This is then subsequently infilled as the flood recedes because the velocity of the current flow drops. Soil particles transported by the river then settle out of the current of the velocity as it reduces. This exposed pipeline can then be partially reburied by sediment, and this can potentially cause failure. And exposure also makes the pipeline more vulnerable to third-party damage. So this project was split into 3 main tasks, and in terms of personal involvement, all of the work that I'm going to discuss is work that I carried out. The first task was a data review, the second was flood monitoring and reporting, and the third involved a 90-page final technical report containing evaluation of the pipeline and recommendations. I'm going to discuss the first task now. This included a desk study of all of the data we had been given and presented with by the client. The client provided us with 15 locations along the 900-kilometre pipeline that they thought were most at risk of flooding, along with previous studies completed and protection currently available to the pipeline. So this included photos that had been taken along the right-of-way, and the image showed on the right of the slide here shows that is damage to a right-of-way access road and culvert. From task 1, I wrote a technical report where I provided an overview of the pipeline and any additional data required to complete task 2 and task 3. So just to fully introduce what SAR imagery is now, is this was the start of task 2, where I began to look into ways of performing the analysis. As I mentioned, SAR is a radio wave used to measure the backscatter and reflectivity of objects on the ground. The European Space Agency, the ESA, allows SAR imagery to be obtained free of charge, and the satellites have a retrieval occurrence of between 6 and 12 days. So you know that the data you're receiving is recent in comparison with other data. It also has the benefit of being retrievable regardless of time of day or weather. So the solution was to employ SAR imagery and remote sensing techniques to detect flooding along the pipeline right of way. Water has a low backscatter and wavelength measured by SAR, and this allowed me to map the water bodies. This then leads me to task 2 of the project, and this was arguably the largest part of the project as it was split up into 4 different steps. And it was all a learning experience as I didn't know how to do this analysis beforehand. So the first step was the development of remote sensing methods. This included doing research and reading journals to develop a methodology for the outcome the client wanted. Step 2 was then applying these remote sensing methods and learning how to use new software that would allow me to analyze large satellite data sets. The third step was then to actually process the satellite imagery, starting with a raw data image to produce a produced vector plot that could be viewed in ArcGIS. And the final step was the reporting stage, where a total of 8 reports were produced for 24 flood areas. Now, the SAR imagery was analysed in an application called SNAP, which is provided free by the ESA, and the data used was obtained from Sentinel-1A and 1B satellites. I used a model builder to develop an optimum analytical process, and this contains many rigorous pre-processing techniques. You can see on the schematic on the slide here, the assessment process involves and this was all developed during the stage of this project and specifically chosen. I won't go into too much detail about each stage, but the pre-processing techniques are used in order to reduce orbital errors, speckle noise, and geometric distortion. I'll now show you what a raw and process plot looks like. So this is a raw SAR image on the left of the screen and displaying the section of pipe in red. And then on the right-hand side of the screen, we have a fully processed vector plot, which has went through the steps shown in the previous slide, and you can see the flooding in blue affecting the right-of-way. As you can see in the image on the right, the build-up of floodwater against the pipeline embankment and a breach of the right-of-way access road. So at this location, a culvert was destroyed, and that obviously ends up being a lot of pressure on the embankment where the pipeline is, and this can cause loading. An assessment criteria was then developed to be able to quantitatively measure the flooding surrounding the pipeline. So as you can see, 1 measures the length of flooding along the pipeline, which is the most important and the one that the client was most interested in. 2 shows the flooding within a 0.5 kilometre area, and then 3 shows the flooding within a 2 kilometre wide area. The main reason for using this quantitative approach was that when the analysis is performed again next year, or if you wanted to look at it historically, then this approach means it can then be compared. These results were then reported in 8 separate reports, 12 days apart, and including 24 flooding sections. The reports included the quantitative analysis I've just discussed in the previous slide. And as you can see on the image of the right here, this is an export from ArcGIS and shows the segment of pipe analysed, the SAR measurement date, flooding, and any adjacent installations. A total of 192 maps were produced during this task. This then leads me to task 3, which was a technical report to summarise the findings from task 2 and an evaluation of each section individually. The report included determining the peak flood at each location, recommendations on how to protect the pipeline from hazards that are present, a review of embankment design, and current flood defence measures. So task 3 considered and evaluated the task 2 results and provided recommendations for the client, basically saying, here are your problem areas and how can they be solved or mitigated. So I've identified a few different ways in which I would improve this process. Firstly, I'd use commercial data, as this would increase the survey frequency. Flooding can rise and fall very quickly, and for a big event, you would expect maybe around a 3-week timeline. So once you identify when the peak flood is, you can then analyse SAR imagery every 3 days, for example, and this will result in a clearly defined flood development and recession curve that identifies the date of flood onset and time to maximum flood. These 2 images on the slide here show the use of remote sensing peak flood warning, as you can determine the flood detection in the upper catchments. On the topographic image on the right, you can see the water is moving towards the pipeline. It would also be beneficial to perform drone surveys. This could be using a one or more combination of SAR, visible spectrum imagery, and infrared sensing. And this would provide additional surveys between the SAR surveys. So some of the further work and recommendations to the client is to perform a yearly review of flooding along this pipeline and along another one of the operator's pipeline, which I'll be completing next year. It's also recommended that the condition of the pipeline to be assessed from the inline inspection data to determine whether there's been any loading introduced due to the passage of floodwater, and if the pipeline had suffered displacement as a result of this. The change in pipeline position between 2 consecutive inspections can be measured as shown in the example on the right. This shows a change in vertical elevation as the pipeline span settles due to self-weight. It's also observed that there's an increase in bending strain in the pipeline due to these movements. However, horizontal displacement is also possible due to the hydrodynamic loading effect that I mentioned earlier. One of the issues that was identified was a block valve that was investigated, and this was at risk of significant flooding. As you can see on the images here, a small earthworks bund had been constructed around the perimeter of the site. However, this was not proven successful in controlling floodwater. The earthworks need to be constructed sufficiently high to ensure they exceed the maximum flood height. To solve this issue, I created an elevation model from the satellite imagery, which determined where the block valve station could be relocated to in order for it not to be affected from flooding. So what was achieved? Well, during the project, a proven methodology has been developed to identify flooding from satellite imagery using remote sensing methods. Ultimately, the client was happy with the findings and solutions that were provided in all 3 tasks. The works allowed the operator to have a better understanding of flooding across the pipeline and significantly reduce the risk of a flooding event at any given location due to the scheduling and protection measures being implemented based on this risk prioritization. In terms of personal achievement, I really enjoyed this project. It was a large project that I was lucky enough to have a lot of input over, and I completed it shortly after graduating. So I feel like this has tested a lot of the skills I've learned at university, and I've been able to apply these and provide solutions and continue to improve and develop as an engineer. So what does this mean for the gas industry? Well, a new methodology has been developed, and this can apply to many networks globally. For example, the method could be applied to any UK network, and this will be particularly important in upcoming years with the growing concern of climate change. And as I'm sure you're all aware, flooding can be an issue globally and can impact assets, including damage to pipelines and particular exposed crossings and above ground installations, which can ultimately result in loss of supply and generating operational issues and additional expense. Remote sensing has a number of advantages, including data collection from remote or difficult to access areas, and in particular with the ongoing COVID-19 crisis. And as satellite imagery improves and becomes more easily accessible, the flooding work could then be expanded to improve remote sensing techniques in the pipeline industry. And this could be used as a geotechnical review of a network to identify and prioritize locations under threat. So this allows prioritization to be desk-based and determine a top, let's say 1 to 5% of the network that would then need to be investigated in field. This includes specific geohazards such as landslide monitoring. For example, if there was a land instability and a heavy rainfall event has occurred, by using SAR and INSAR imagery, which combines 2 SAR images, this can be used to determine changes in land surface. You can then compare these images before and after the event and determine whether monitoring or further investigation needs to take place. And then you can link this to the movement of the landside mechanism and how this will affect the pipeline. This is something I'm looking at currently in my MSc dissertation. And remote sensing isn't just limited to the geohazard discussed today. It can also be used for vegetation monitoring along the right-of-way and subsidence. So to summarize, I think the future of remote sensing looks really promising in terms of helping pipeline operators manage the integrity and therefore safety of the pipeline, which I'm sure everyone will appreciate is an important objective. So I hope we can develop and utilize remote sensing techniques within the pipeline industry. And that takes me to my last slide. Thank you very much for joining the presentation. I hope you've all enjoyed it. Please may I take any questions from the panel?
Superb, Rebecca. Well worth the wait. Just shows the importance of remote sensing within this current world with the recent landslides in particular in the Scotland area. So we'll probably see this technology in the near future coming in as business as usual. So we'll go to our first question from Duncan Wong, please.
Rebecca, it was a very, very interesting presentation. Just want to know, is this system already up and running? And where is, I mean, in which country or where is supposed this system has already been, in place?
Thank you for your question, Duncan. So this project was in Kazakhstan, Central Asia. So this was our kind of trial project to see that it was actually going to work and be able to prove that we could detect flooding along pipeline right of way. So we will be completing that project again next year in the same region. But it's by no means restricted just to that region. Anywhere with any type of flooding or heavy rainfall geohazards in general, it could definitely be developed further. So I'm looking forward to doing that.
Thank you, Rebecca. Thank you.
Thank you, Duncan.
For our next question, we'll go to Graham, please.
Hi, Rebecca. Really thorough and a super subject. I'm really interested in what you, from a personal perspective, found the most challenging aspect, and more importantly, how did you overcome it?
Yeah, thank you, Graham. Good question. I think for me, the most challenging aspect would have been developing the methods to analyse the remote sensing techniques. I think in terms of the most interesting, it ended up being able to I think it's all well and fair being able to analyse and say that the flooding's there, but being able to then compare that with ILI inspections and the integrity side and risk side of it, being able to compare the remote sensing and the integrity side, I think that was maybe the most challenging, just second to actually developing those techniques that, you know, they were new. There was some hiccups along the way, but you know, trial and error, and managed to develop as an engineer along it, and mix those two things together, which was really interesting.
Thank you.
And we've got time for one last question. Jane, over to you.
Thank you. Rebecca, that was excellent, very, very interesting and very, very topical. I think some of the slides in the middle of your presentation, which showed the raw data that you were working from, and then how you transformed that into something that was visually understandable, were very, very significant, because obviously engineers understand visual information very, very quickly. Could you just describe to us a few of the challenges that you dealt with in that process?
Yes, so I think that process at the start, because there wasn't really any sort of setup beforehand, the techniques had been used in a few various areas, but definitely not with pipelines and this sort of terrain. So I think initially the challenges would have been getting that model set up. In, I think the most important thing for me was knowing that we were detecting water where water was actually there, so we weren't doing any false positives and alerting the operator incorrectly. So I think that challenge was overcome by, we had drone imagery and aerial imagery. So for example, we would compare the flood map that I had produced with, for example, a drone imagery or aerial imagery from the same day and roughly around the same time. So I was 100% certain that there was going to be flooding at that location. And I think that was the main thing. You don't want to, you know, tell the operator that there's problems where there's not problems. So I think it was ensuring that that was an accurate representation of flooding along the right of way.
Excellent, that's great. Thank you very much, Rebecca.
Thank you for your questions.
Superb, Rebecca. That concludes Rebecca's presentation. Congratulations and well done for an excellent presentation on that. So we'll now move to our next finalist, David Noakes, who's a network support engineer at Wales and West Utilities. David won our Welsh section, and he's going to talk to us about the impact of power generation and biomethane analysis. So over to you, David.
Yeah, just share my presentation.
Sure. Okay, that's coming across now, David.
Perfect. All right. Hi, everyone. Welcome to my presentation. And today I'll just be taking you, oh, hold on, I haven't put on my camera, have I? Right, sorry for that. Okay, hello, welcome to my presentation, and today I'll be talking to you about the impact of power generation and biomethane on analysis. Firstly, I'm just going to be giving you a brief introduction just about myself and how I got to talking to you today about analysis, and then I'll be taking you through just a recent history of the rise of these types of requests. I'll then split off and talk about power generation and biomethane separately and how both of these requests have affected our network and the way in which we conduct analysis. And then finally, just a little view of what's in store in the not too distant analysis future. Before I begin my presentation, but just a brief introduction and just tell you a little bit about myself. My name is David Noakes. I'm 28 years old and I graduated from Cardiff University with a master's degree in mechanical engineering in 2014. Where I went straight into the gas industry, and I've now been part of Wales and West Utilities for around 6 years now, 4 of those in an analysis role. Many things have happened in these last 6 years. The UK have voted to leave the European Union. Donald Trump defied the odds and won the US presidency and subsequently lost it. The world is in the grips of a global pandemic, which has changed the way we live, work, and interact with one another. And for those of you who saw my previous presentation, I did make a slight suggestion that England winning a penalty shootout was one of the most astonishing things to have happened in the last 6 years, but don't worry, I'm not going down that road this time. So something else to have happened in the last 6 years. Oh yeah, Scotland qualified for a major tournament. That's unbelievable, I know. Sorry, Stuart. Anyway, getting a bit more serious now. If we turn our heads to the gas industry, a major change seen on our network and networks across the UK is the rise of power generation and biomethane. Over the last 6 years, we've seen a large amount of interest in these types of requests. Gas-fired power stations have been around for a while, but only recently have we seen the interest in these peaking power generators expand greatly. And also with the lean more and more towards greener energy, the interest and uptake of biomethane plants has also grown. Let's talk about that interest first and have a look towards power generation. From this graph, we can see from the blue line, the interest in power generation increasing year on year until last year, we've received a peak of just shy of 600 requests. We have seen a decline in 2020, but that could be down to the pandemic or the electricity market suspension in late 2018, which has since been reinstated. In the last 4 years, we've gone from having 11 connected power gen sites to 41 connected, with a further 28 sites looking to connect. From the purple bars, you can see from 2021 onwards, the potential sites that could connect, and that is based on the most recent electricity market auction. So therefore, power generation train won't be slowing down anytime soon. Turning to biomethane then, the amount of inquiries, again seen on the blue line, peaked in 2017, where we had 75 inquiries. We currently have 19 power generation sites with a further 6 accepted sites looking to connect. However, we have seen a decline in recent years. The interest levels can vary, so this decline could change back and depending on incentives given by the government, but interest is expected to grow again, according to the Navigant Pathway to Net Zero report, which I have referenced in my paper for this competition. And so therefore we need our analysis process to be the best it can possibly be. The impact of power generation then. As you can see from a pressure and flow graph taken from one of our sites, you can see the effect that these sites have. The black line represents the flow from the site, and the light blue and blue lines, the solid lines, represent the different pressure outlet readings. Peaking generators tend to switch on when the electricity demand is high. On a typical day, that would mean you'd get 2 peaks on a typical diurnal swing, a breakfast and dinner peak, if you will. If we look closely at one of these peaks then, as the power gen site switches on and off rapidly, the pressure drops and increases as well. And it's this situation which we must analyze carefully. Generally, for analysis requests, we have 2 modes of analysis. Steady state analysis, which we use on our below 7 bar models to determine whether the new load is acceptable during peak demand. And also slow transient analysis, which we use on our above 7 bar models, just to check whether our storage capabilities are sufficient to meet this new demand. Just a quick note on this, power generation has also had a big effect on our storage, to the point where systems which have previously had a huge surplus in storage are now in deficit or close to being. So therefore, we introduced a peak day percentage nexus to ensure that these sites can operate normally, but only to a specified demand level. Once past this level, the site must run at a flat rate to avoid any storage issues. Going back to our processes then, a major change in the way in which we conduct analysis for these fast ramping power gen sites is the introduction of fast transient analysis. This type of analysis allows us to examine the ramp rates of power gen sites more closely as they switch on and off. So what do we need to conduct fast transient analysis? Just a couple of pieces of information from the customer is needed, aside from the hourly flow. Firstly, the gas meter or site location, so we can determine the distance between the connection point and the site, and in turn work out the new main and service lengths. The toolbox program is then used to calculate the minimum allowable diameter of the pipes leading to the connection point, from the connection point to the site. Using toolbox allows us to, and ensures that the pipes I design don't exceed the limitations set out in the MP14 regulations. In this case, making sure that the velocities don't exceed 40 meters a second in the main and 15 meters a second in the service. Lastly, what we need from the customer is the ramp rate of the site, which is given to us via an industrial load form. From this, we can then create a profile to simulate the site switching on and switching off. This is just a snippet of our Synergy model, just to show you kind of how the site will look as it's set up on Synergy just before its fast transient run. Taking a closer look at the profile created then for fast transient analysis, we can see that we begin with the initialization period of about 2 minutes just to let the model settle in, and then this profile will simulate firstly the site switching on quickly, in this case over the course of 2 minutes, and then the site switching off. And in every case, we analyze for an emergency instant switch off. Once the model has been run and the fast transient has been analyzed, then this is an example of the type of results we receive. Interested in two areas of this result. Here, as the site switches on, and here, as the site switches off, similar to the profile I just showed you. We are looking to ensure there are no pressure spikes during these two scenarios that take the pressure over or below the allowable limits of the upstream network. To ensure we are fully covered for all scenarios, we use this profile both at peak demand and at summer night demand, which we analyze at 5% temperature sensitive and 30% industrial demand. We do this because pressures are higher in the summer, and therefore we need to see if the pressure spikes above the peak level operating limit of the network during an emergency switch off. Turning our heads to biomethane now, the impact of biomethane. Whereas for most inquiries, we are interested in what happens during peak demand, for biomethane requests, we are looking to see how the biomethane site reacts during low demand periods and if they can export their requested amount all year long. In an ideal world, the biosite would be able to run at a continuous flat rate without any disruption. However, this is not always the case. So what do we need to conduct our biomethane analysis? Similarly with the power gen, we need to know the distance from the site to the nearest connection point on our network. We can then again work out from this the size of the new main, which with the help of the toolbox program. And lastly, we just need the requested export amount from the customer via an application form. And again, this is an example of the modeled setup for the biomethane site. It's seen on the right here. It's similar to the power gen setup, except now we've got a supply at the end of the red main. Let's have a look at an example then using our actual flow data from our SCADA system. Say if the customer wanted to export 500 standard cubic meters of biomethane into our network, then it would not be possible during low demand periods. However, it's not just as simple as just looking at actual flow data and making a call on how much the customer can export. There could be more than one site feeding into the same network, and also we don't know how the biosite will react with the other feeds once it has connected. That is why I use modeled data and flow data together to come up with a true export rate. The way we do this is by sticking the biosite onto the model, like I showed you on the previous slide, switch it on pressure control at the MOP of the system, and scale the model down in increments as shown here on the next slide. This is just an example of the increments used, but you can use as many as you like. The industrial scale does not match the non-industrials, just because in reality, the industrials wouldn't see the same proportional decrease in demand the same way as a house or flat does. So if we look at some example results from our modeled data, doing this ensures we get a good overview of how the biomethane site will react with the other feeds in the same system during different demand periods. As you can see from the far right-hand column, this is how much of the total system flow would go through the biosite from peak demand all the way down to a summer night demand. We can then incorporate this into our flow data to show us exactly what the biosite would have been doing if it had been connected for the past year. This, of course, is just a snippet of the results and not the entire story, but we are interested in the available capacity column, which shows us basically every hour's data for the past year and shows us how the site would have reacted. These results can then produce the following graphs, which then go into the design study, which is sent to the customer. A random day is chosen in the winter months just to show how the biosite would export during the colder months, where there is more demand. And similarly for the summer, again, where there is less demand. And as we can see from this example, the biosite would struggle to export during low demand periods. And then we have our all year round view, on which we can say that between April and October, the biosite would be struggle to export the full 500 standing cubic meters, and therefore would have to accept a reduced amount during these months should they wish to progress. All of these amounts are broken down in a capacity study for the customer to see how the results were obtained. Once the site is connected, we will continue to monitor the site to ensure that the analysis we have conducted is working as predicted. And although this presentation talks about biomethane analysis, this could actually be extended to green gas inquiries in general, or the same logic still applies. Looking to the future then, whilst we are also always looking to improve our power gen and biomethane analysis and share our best practices, we're always looking further to the future to be ahead of the game. With the 2050 net zero target, Wales and West utilities and the gas industry as a whole needs to adapt and contribute towards this goal. One way we can do this, along with the predicted uptake in biomethane, is the introduction of hydrogen. Hydrogen and hydrogen blending will provide a huge challenge for analysis, and is vitally important that we are satisfied with the results and ensure that all scenarios are covered before implementation. If, as I mentioned before, that we're expecting to see an increase in the amount of biomethane sites, then we will need to look into ways to help green gas export into our network. One of the ways that is being explored is through the OptiNet project, which Wales and West have been working on alongside Cadent and Passive Systems. The purpose of this project is to explore different ways to optimize the gas networks applications, such as smart pressure control, compression to higher pressure tiers, and storage solutions at time of low demand. The smart pressure control trial is currently being set up on the Wales and West network, and if successful, it could then be implemented to other parts of the network. Finally, another branch of analysis that we've not experienced before until recently was unregulated demand. Since this demand is unregulated, the site will be taking gas depending on what the network pressure is at the time. We have already had consultation with customers and also with other DNs across the UK to workshop the analysis process for this type of request. It's expected that we will be getting more of these inquiries, so it's important to shore up our processes early. Thank you to everyone for listening to my presentation. If you have any questions, I'll happily answer them. Thank you.
Superb, well done, David. Congratulations, that was brilliant. Good to see some of the biomethane work. A lot of talk is on hydrogen, but excellent to hear some of the biomethane work going on there. So we'll come to Graham to ask David first. Over to you, Graham.
Hi, David. Very thorough and very good presentation. Thank you. David, I'm interested particularly in how you found the challenge of interacting with the other networks, and how you found that whole process and what you benefited from.
It's definitely useful just knowing, especially recently we had a discussion about the unregulated demand with the other networks, and it's useful just to bit of sort of confidence in ourselves in what we're doing is right, but also like getting a bit of knowledge from them as well about what they're doing and applying it to ourselves as well. And as it turns out, we're all doing roughly the same similar thing, so it's definitely useful to talk to the other DNs and just share our best practices.
Thank you, sir.
Okay, great stuff. David, your camera's off at the moment. I don't know if you want to turn it on. We'll go on to our next question from Duncan.
Thank you, Gordon. David, it was a very good presentation. In one of your slides, I saw that during summertime, the demand for biomethane is low. So how do you balance the supply and demand during those periods?
Yeah, as you saw from those slides, it's very difficult to say that, oh, you can definitely export that amount during that period when you can clearly see that during the course of regarding to our flow data, it doesn't say that. But that's why there are projects ongoing, such as the OptiNet project, as I mentioned, where we are looking to use smart pressure control to be able to adjust during those times. Because what I did during those analysis was not adjust any of the outlet pressures on our current sites. But what we can do is adjust those outlet pressures on those feeds to be able to help the biomethane site export. So whereas like the things we send back to the customer are how it's currently set up, we can always make suggestions into how to help them progress and be able to export more during those months, because we want to be able to let them export as much as they can.
Thank you, David. Good question. Good answers. Thank you.
Thank you.
Brilliant, David. And we'll just come to Jane for one last question. Over to you, Jane.
Thank you, Gordon. David, that was excellent. Fast transient analysis is, I think, a challenge for anybody to present. Do you see any scope of using the approaches that you described and that you've developed to look at the increasing mix of renewables in terms of supplying energy? So gas networks supplying energy as an energy output together with electricity due to renewables. Is that something that you're looking at?
It's not something that I've personally been contributing to. Like, I'm not sure, to be honest, about the mixing with electricity renewable. But I know as a company we're always looking to sort of look at any things like that. So but yeah, using our sort of processes, even though it says biomethane analysis, it can be applied to any sort of green gas renewable analysis. So it's not just a biomethane specific, but it can be applied to green gas in general.
Okay, that's excellent. Thanks very much, David.
Okay, brilliant. That concludes David's presentation. Congratulations, excellent presentation, David. Well done. Okay, so that's our fourth finalist of the session. Now we're going to move on to our last one. Crystal Chan from one of our Feds Heat, first runner-up. She's going to talk about maximising the recovery of biogas energy. Crystal is from the Government of the Hong Kong Special Administrative Region and an electrical and mechanical engineer. So over to you, Crystal.
Yeah. Does everyone can see the screen right now?
Yeah, that's looking great.
Yeah, so let's get started. Good afternoon, Duncan, Grace, Graham, Jane, and all ladies and gentlemen. This is Crystal Chan. After graduation from Imperial College London with a master's degree, I started my professional career in the Drainage Services Department of the Government of the Hong Kong. As a gas and mechanical engineer, I'm currently responsible for the design, project management, operations and maintenance of the biogas-related utilization projects and processing facilities at the various sewage treatment works. Before I start to introduce my topic, may I ask you a few questions? Have you ever wondered what happens to your food waste when it has been collected, similar to food at a landfill? Or have you ever thought about turning the food waste into the energy source for generations of electricity or heat, or even turn it as a fuel for your car? Sounds amazing, right? So in this presentation, you will probably define us the reasons or the magic behind. So today, I'm very pleased and honored to be with you and sharing a fantastic and interesting topic that is maximizing the recovery of biogas energy from anaerobic co-digesters with sewage sludge. So let's get started. Municipal solid waste as well as the limited landfill space are the two major challenges in Hong Kong facing nowadays. According to a statistic provided by the Environmental Protection Department, we can see that there is a 31%, which is a major component of the food waste amounts to the municipal solid waste. While the disposal of the biodegradable food waste at the landfill is unsustainable as well as environmental undesirable because it would generate about leachates as well as landfill gases. So what comes to the solution is that to tackle the issues of the food waste, we have provided implementations of anaerobic co-digestion of sewage sludge and food waste is an innovative as well as sustainable solution from turning the waste into an energy source. Actually, this is a sustainable development. So triple bottom line framework is used to evaluate the performance of anaerobic co-digestion in three different aspects, which is namely the social, economical, as well as environmental. So in terms of the social aspect, anaerobic co-digestion tackle about food waste as well as limited landfill space problems. And from the perspective from the economic points of view, maximizing the recoveries about the biogas energy is a major concern of my study, and the strategic framework of the biogas utilization is proposed. And the final one is about the environmental aspect. The study successfully formulates a sustainable framework for the biogas utilizations, which is an innovative as well as sustainable development in the gas industry. So it can be also a feasible plan for the private sector to operate in a very efficient as well as effective manner. So before formulating the strategic framework, I've adopted a 3 stages approaches. Or maybe you will wonder, what is the kind of the anaerobic co-digestions? Indeed, anaerobic co-digestion is a biological process, and after this kind of the pre-treatment, food waste as well as sewage sludge will enter into the digester to have the anaerobic co-digestions in absence of the oxygens. So biogas as well as digester will be generated in this process. So before formulating the strategic framework of the biogas utilizations, I've adopted 3-step approaches by analyzing the biogas composition. And the second one is to analyze about the synergy effect of the anaerobic digestions and review the current biogas utilization practice. So in step 1, biogas is a form of the renewable energies, which contains around 55 to 65 of the methane, where the remaining contents are most likely the carbon dioxide. And Hong Kong Drainage Services Department has been operating sludge treatment for many years and generated biogas to supply the electricity. However, it is the first time of the Hong Kong to adopt the innovative anaerobic co-digestions of the food waste as well as sewage sludge.
Hi, Crystal. Sorry to interrupt. The slides aren't actually moving. Do you want to try and share your screen again?
Okay. I mean, I quit it again and then to start with the new one.
I would continue where you're off, but yeah, that's them. We've not actually seen the slides, so if you just continue there, and hopefully we'll now be able to see the slides move as you progress. Okay, so is that all right for the slides itself? Yeah, that's looking good now. Okay, so maybe I can repeat once again. For the step, I need to restart it once again, or just similarly start with this? Yeah, I would just continue as planned. We heard the information before, so if you just. Okay. For the step 1, we have to analyze about the biogas compositions. So in step 2, we're going to analyze the synergy effect of anaerobic co-digestions. So in Hong Kong, our Drainage Services Department has been operating such anaerobic digestions for many years and generated biogas to supply the electricity. However, it is the first time of Hong Kong as well as Drainage Services Department to innovatively adopt the anaerobic co-digestions of food waste and sewage sludge. So therefore, feasibility studies of the anaerobic co-digestions by the DSD at the laboratory test have been carried out. And the result shows that there is a synergy effect of a significantly increase of 30% of the biogas. And in these studies, we are going to identify the strategies to maximize the recoveries of the biogas energy. Apart from the increase of the 30% of the biogas generations, synergies of the co-locations as well as co-treatment, reductions about the sludge volumes, or the greenhouse gas emissions are the major advantages of using the anaerobic co-digestions. And the third step is that we need to understand about the current situations about the biogas usage. To enhance the biogas utilization, Drainage Services Department is currently using the combined heat and power as well as microturbine to generate electricity as well as the heat. From our study, we found that there is a major problem because of the low utilizations of the thermal efficiency. So that's why I come to our main part is that we need to construct a very strategic framework of the biogas utilizations. So in order to enhance the biogas utilizations and for economic performance of the CHP system, I propose a strategic framework for conducting a study to identify the improvement as well as explore the other feasible solution. Combined heat and power microturbine is the first strategies, while the second one is for the gas conditioning. So it would be go through one by one. In terms of the combined heat and power as well as microturbine, electricity efficiency as well as thermal efficiency will come up with the total energy efficiency. And then in order to enhance the heat and efficiency maximizations, we need to construct, there is 2 methods for doing so. The first one is about the tri-generations and an adoption of the absorption chiller. In order to enhance the biogas utilization efficiency as well as the balance of the thermal load, we have applied a retrofitting schemes to the existing tri-generations. You may wonder what is kind of the tri-generations. Indeed, it is a combination of the CHP modules as well as thermal-driven chillers, which is named about combined cooling, heating, and power system.
So energy saving as well as emissions reductions are the main benefits of the trigeneration system. And the chilled water producer can use it for the district cooling system, or it can supply to the powerhouse for the cooling. And to satisfy different cooling as well as heating demands in the different sections, strategic controls of trigeneration is adopted for capturing the thermal energies from the CHP. For example, in the summer, the chilled water be used to cooling the exhaust gas as well as the jacket hot water. While in the winter, the digest heating is given a high priority, and the surplus wastewater is used for the cooling itself. So in this kind of study, not just only learn about the technical side, but from the project management side, so it can be also benefit for both of the items. And here comes to the performance analysis. The result shows that the overall energy efficiency is equal to the power generation efficiency plus the thermal energy efficiency. And from the study result, we can show that the combined heat and power, we have the average of the 80%, and the traditional combined heat and power is just only 30.6%. So there is increase about the 32.4%, which is a really good outcome. Method 2 is about the thermophilic digestions as well as thermal hydrolysis process. Anaerobic digestion is limited by the hydrolysis stage, and to maximize the utilizations of heat and electricity, thermal hydrolysis as well as the thermophilic digestions are introduced. If the heat loading is enough, we can use the thermal hydrolysis as a pretreatment for the mesophilic digestions, so that we can increase about the bar gas yield as well as electricity productions and further reduce about the bar solid volume. If the heat loading is a massive size, so we can use the thermophilic digestions with a temperature over 55 degrees Celsius to replace the mesophilic digestions. So we can further generate about the bar gas yield as well as electricity productions as well. After we share about some strategies for maximizing the thermal efficiency, so we can also introduce about the strategies for enhancing the electrical efficiency. So on-grid connections for the CHP generation system is one of the solutions. According to the agreement with the power supply company, China Light and Power Company, power generated by CHP as well as micro turbine is fed directly into the electrical switchboard for the water heater house for the further supply to the electrical appliance, like the fan or ventilation, such kind of things. So the reliability of the electricity supply is further increased. Apart from the combined heat and power as well as micro turbine, the second strategy I've proposed is about the gas conditioning. Upgrading of the bar gas to biomethane and injecting into the natural gas network is an efficient way of integrating the bar gas into the energy sector. Biomethane can then be used as a substitute for natural gas. So we can study in one by one. The first option is to blend the bar gas into the gas network directly for the supplies to the gas customer. So the bar gas generated type of sewage treatment works could be blended into the gas network directly for the supply of the gas customers. And the study shows that there is a 87% of the efficiency, but it also depends on the energy source itself. And the second option is to use the bar gas as a fuel as well as feedstock as the bar gas for the gas production plant. And the efficiency can reach to 90%, and it also depends on location. And the final one is about the fuel cell technologies. The efficiency can reach to 90% with the breakdowns of electrical 50% and thermal efficiency of the 40%. And major advantages is that it will have a low economic impact. Apart from formulating the strategic framework of the bar gas utilizations, I've also successfully identified a strategic decisions matrix of using about the framework, including about the economic, environmental, as well as technical side for making decisions in the short term as well as in the long term. In short term, combined heat and power as well as micro turbine is widely adopted in during the services department. For the large-scale sewage treatment facilities or the high bar gas generation rates, we're most likely to use about the thermal hydrolysis or thermal digestions, because we can enjoy about 85% of the efficiency. And the second option is go to trigenerations and absorption chiller. For the small-scale sewage treatment facilities or low bar gas production rates, we propose to use about a micro turbine to convert about to treat our sewage sludge, because there is no pre-certification process is not needed. However, apart from the technical side about the energy efficiency, we also still need to consider about the economic as well as environmental aspect. Combined heat and power and micro turbine will have a very high economic, capital as well as maintenance cost, and it would generate about the oxide, the nitrogen oxides as well as the fine particles. So in the long term, we're going to have different strategies to introduce. That is the gas conditioning strategies. So we can see that the technical side that energy efficiencies can go up to 80%, and there is no capital as well as maintenance cost, and there is low emissions of the air pollutants. But the major concern is that we need to care about the locations of the gas sources. So we mostly apply the gas purifications when the sewage treatment works is near the gas production plant, so that the distance transforming the biogas into blending into the network will be much shorter. So here is the short-term as well as long-term strategies. And apart from anaerobic digestions, Drainage Services Department has also the other feasible options. New technologies like to boost about biogas generations. Ultrasonic pretreatment of sludge of anaerobic digestion is one of the feasible solutions. Indeed, it is an effective and mechanical pretreatment method on the surface activated sludge to boost up the biogas production, because it can further break down about the bacteria into smaller pieces and increase the biodegradability. As we can see the result right here, the left-hand figure shows that biogas production rate is increasing, and the right-hand corner shows that the biogas production rates before the pre-trial is around 30,000 m³ per day. But after we have the applications of the ultrasonic pretreatment, it will increase to nearly 4,000 m³ per day. So, which is a really amazing result in our shut-in sewage treatment works. To maximize the use of the biogas generated during the sludge of the pretreatment, we usually to increase about the CHP generators as well as the micro turbine to enjoy the benefits. So here comes to the conclusions. I would like to suggest in the 4 development directions. The first one is to boost about the biogas production rates. For example, we can introduce about the cold digestions as well as the ultrasonic pretreatment of sludge to increase about the biogas production. And the second one, I have successfully proposed about a strategic framework for the biogas utilizations, divided into short-term, long-term, as well as in the aspect of social, economic, as well as technical side. And the third direction is the co-digestions can operate private spaces efficiently and effectively. Finally, the fourth one is the energy-neutral sewage treatment works. Government, university, private sector, and citizens should join hands and join the energy as well as carbon-neutral world. So I hope you understand the matter behind of the anaerobic digestions, and I hope you have a really good sharing with all of you. So that's the end of our presentations. If there are any questions, please feel free to ask.
Awesome presentation there, Crystal. Really interesting to learn the different processes and strategies that you're adopting to optimise that efficiency of biogas. We'll come on to the judges. Jane, we'll go to you first to ask Crystal. So over to you.
Thank you very much, Gordon. Crystal, that was an amazing presentation. The scale and scope that you've covered was phenomenal. My question is actually sort of quite basic. You've talked about the excellent use of food waste and sewage sludge. In terms of food waste, what do you think needs to be done to make sure that people separate food waste properly and accurately?
Actually, thank you for your questions, which is really an interesting topic, because the food waste is the first components to enter into our sewage treatment works. So before that, I can use the configurations to show that. So actually, here is the process. Oops. So just wait a second. So here is the process flow for the food waste as well as sewage treatment works. So how we can encourage about the citizens to separate about the municipal solid waste. Basically in Hong Kong, there is a separation system for the solid waste itself, but for the food waste itself, Environmental Protection Department, which is one of the department of Hong Kong, is going to launch a food waste separation schemes at the end of this year, maybe the early of the next year. So the government may implement, in the short term, we may implement the legislations or to formulate different kind of strategies to encourage the citizen to separate about the food source. For example, the proteins or the carbohydrate stuff, or to have separates about the milk. Because it is really important question, because the components of the food waste is directly influence about the biogas generations. Most likely, the protein would be much more benefit in generating the biogas, because the bacteria usually to break down the protein itself. So for the government itself, different kinds of legislations and strategies should be implemented to encourage the citizens to have the food waste separation system. And as a citizens of everyone right here, we also to share about the corporate social responsibility, that we need to protect the environment and to save the resources for our future generations, not just only in the social aspect, but also in the environmental as well as the economic points of view. So as a citizen, we need to bear a very clear mindset to bear our responsibility to share, to split our food waste in the separate system, and then to match with the government policy. And as the parties of the Drainage Services Department, we'll try our best to match with the different kinds of the food waste compositions and try methodologies to optimize about the food waste to maximize the biogas utilization rates in a high standards. So that's it answers of my questions. And
that was,
yeah.
Sorry, Crystal, I was just going to say that was a very comprehensive answer. Thank you very much. And I think we need to learn from this project in the UK.
Yeah, that's a really great idea. So yeah, thank you for your question. So just one more point to come up is that anaerobic digestion is the breakdowns of the organic materials into the biogas. So the component itself, for example, the proteins or starch or the carbohydrates is really important. So separation of different food waste is really a first important step for every citizen to deal with it, as well as share the corporate responsibility as a CSR citizen. So that's all. The government, the Drainage Service Department, and citizens share the same responsibility to reach about the energy neutral world. Thank you for your questions, Jane.
Thank you very much. Thank you.
Thanks, guys. We just time for a quick question from Graham.
Your part in the process, Crystal. How did you manage prioritization? Because it's an incredible, intense process that you've gone through today. How did you manage prioritization?
Thank you for your question. So indeed, it is really a broad topic to study, which is also very innovative, as well as sustainable development projects in Hong Kong, because Hong Kong as well as Drainage Services Department haven't applied this kind of technologies before. So how can I prioritize the task is that firstly, I need to understand about the biogas compositions, like what kind of the methane compositions right there. And based on the biogas production rates, I need to strategically identify different kinds of the strategies, no matter in the short term or the long term, from the perspective of using the triple bottom line, like the economic, social, as well as environmental, to analyze different approaches. For example, combined heat and power or microturbine use it for the short-term strategies. And for the long term, we can use about the gas purification process. So after we identify the gas components, the biogas production rate, and I need to figure out about the formulate strategic framework for the biogas utilization. So the strategies for prioritizing the task is using the plan, do, check, act. Plan is to have a basic research about the biogas compositions, and based on that kind of the statistic, I need to formulate and plan a very strategic framework to effectively and efficiently to enhance the biogas utilizations. So in the third page is that we need to ask, so in currently, Drainage Services Department is conducting a trial study of the food waste as well as sewage sludge at the type of sewage treatment works. We have 10 tons of the food waste. We have the trial at the plant, so it is in operations in reviewing the statistic. So answering the questions, how can we prioritize the task, is that we need to identify the major problems. And then based on the statistic, we need to have the plan, do, check, ask. So throughout this kind of projects, I do really appreciate the chance to enter into the project, and then not just only to have a enrich into the technical background, but also it's our personal development, no matter in the interpersonal skills and different kind of soft skills like the project management, how to handle about the design and operation and maintenance and such kind of things, and started to analyze using the triple bottom lines like it's economic, social, as well as environmental. So thank you so much for your questions. So which is really good questions to ask.
Thank you.
Brilliant, Crystal. So well done. That was a great presentation. A lot to digest there. And Crystal is all finalists. Their paper's going to be on GI. So if you do have any questions on any of the technologies seen, we can pick up those questions offline. So well done, Crystal, and thank you for your presentation.
Yeah, thank you.
Okay, so that's us. Well done to all finalists. You can do no more. We can all agree that all presentations were fantastic, and I'm glad it's not me who's deciding the winner. It's now up to the judges, where they will go away to deliberate and choose their winner. This should take about 30 minutes, so we're going to, should take about 30 to 45 minutes. So we're going to reconvene at 1:45 for our third and final session, where we're going to announce our 2020 YPPC champion. So hopefully see you all then at 1:45 for our final session. Thank you, and see you then.